This video will demonstrate easy-to-follow techniques to accurately diagnose a misfire on a DIS or distributorless ignition system. Our subject vehicle is a 2000 Chevy Impala with a 3.4-liter engine and about 130,000 miles on it. The complaint is a misfire at idle and during acceleration. The diagnosis started by connecting a scan tool and observing the misfire counts. There it is, cylinder number 2 shows a couple of misfires. Unfortunately, it doesn't always work out this easy. When your scan tool doesn't show any misfires, or if you don't have one, here is an alternative way to find which cylinder is losing spark or if it is an ignition problem at all. Connect a timing light or inline spark tester to each one of the ignition wires. Start the engine and watch the light for a continuous flash. If the light skips like this, you just found at least one of the cylinders that is misfiring. Every DIS coil fires 2 cylinders in an electrical loop. View our counteroffensive DIS video available on our website or YouTube for function-detailed information. To determine which 2 cylinders are being fired by each coil, you will first need the firing order of the vehicle, also available on our website. Split the firing order in half and move the second half under the first. This means cylinders 5 and 2 are fired from the same coil, and so on. The spec for suppression ignition wires is no more than 8,000 ohms per foot. The maximum resistance of the secondary winding of this coil is 11,000 ohm. In this circuit, we have one wire approximately 3 feet long, which equals no more than 24,000 ohm. Another wire at approximately 1 foot, which equals no more than 8,000 ohms, and the secondary coil winding should be less than 11,000 ohms. When we add it all together, the loop should not read more than 43,000 or 43K ohms. When replacing the spark plugs, insert one lead of the ohm meter into the spark plug boot to cylinder number 2, and the other lead into number 5. Our reading is 71,000 or 71K ohms, which means it is well over the maximum allowed for this loop of 43K. Now it is worth the time to take it apart to inspect the components. Look at the corrosion on the wire boots and the coil towers. This vehicle definitely needs the ignition wires and coils replaced. When a coil is not firing at all, the ignition control module or ICM could be the cause of the problem. Testing the ICM on the vehicle can be done with a test light like this. Remove the coils and clamp one end of the test light to one of the spade terminals on the ICM that connect to the coil. Then touch the test light probe to the other terminal and crank the engine. The test light should flash like this when the ICM is firing the coil properly. Repeat this test for all coil connections on the ICM. A misfire can also be caused by a fuel or compression issue which does not show up with the timing light test. This is a way to short out individual coils on a DIS to determine which cylinder is misfiring. You will need carbon-impregnated vacuum hose, not plastic hose, side cutters, and a test light. Cut the vacuum hose to approximately 1.5 inch pieces, one for each coil tower. Insert the pieces over the coil tower and inside the ignition wire boot. Ground the test light to the engine block and start the engine. As the engine idles, touch the pointer of the test light to each piece of the vacuum hose, shorting the ignition to that cylinder. The engine should then noticeably misfire. If a misfire does not occur, that cylinder is already misfiring. A common cause for a no-start, no-spark situation on this type of system is a defective crankshaft position sensor, or CKP. This CKP is an AC voltage generating type. The specifications for this sensor are available on our website. To test it, disconnect it from the ICM, then connect an ohm meter like this. The resistance is 1023 ohms and within specs. Then turn the meter to AC volts and crank the engine. The sensor must generate at least 1/2 volt at normal cranking RPM to be within specs. Be careful, when the RPM is slow, the voltage generated will also be low. We ended up replacing the ignition wires and coils on this vehicle, and it again runs like new.